Hi, Shalon. My name is Jade, she, her pronouns, and I would love to help you. Okay, so I am just going to share my screen real quick. And there you go. Okay, so you were looking for the equation for dissociation of NH4 NO3, right? That's ammonium nitrate, right? Okay, this is actually a little bit easier than it seems. All you gotta do is figure out, okay, so what is the cation, right? Cation and the anion. Cation is going to be our positive one, anion is going to be our negative one. So the positive one, right, is going to be NH4. Let's think about why. Nitrogen has 3 hydrogens normally, right? This is ammonia with a lone pair. That's because it has 5 electrons normally, so it needs 1, 2, 3 to fill and be happy. Okay, wonderful. But what if this electron pair were to go off and grab just an H+, right, a proton? What you'd end up getting is NH4, something that is fine, it can work, but it has this positive charge. It's not super happy to be involved. The NO3 we can find in our polyatomic tables. This is the nitrate, right? And so the polyatomic tables will tell us that this is a -1, right? If you're having trouble remember those, sometimes I find that SO4 2 minus, PO4 3 minus, NO3 1 minus is kind of hard to remember, but the acids are a little bit easier to remember. So HNO3, H2SO4, they have a little bit more of a ring to it. H3PO4. So if you do that, you can just take off the hydrogens, right? And that will give you the negative charge, right? So 1 hydrogen on HNO3, 2 on for SO4, and 3 for PO4. Okay, so all we got to do is when it gets into water, right, it's going to dissociate, right? Dissociate, so dis apart, and then associate meaning the bond, right? So my NH4 plus is going to become separate from my NO3 minus. And that's it. You just got to put aqueous after it. Your teacher may or may not want you to put the brackets. You should look at other examples that they've given you to see exactly how they want you to write it. Yeah, and that's it really. Other questions that you might get based on this one are they might ask you for KD, which they'll call the dissociation constant, or rate of dissociation constant. So when you're doing rate problems, K sub D will come in. How fast will something dissociate? It's very similar to the Ka for acids or Kb for bases. Or another thing is K sub Sp. Now that's something that confuses people. It's called the solubility product. Solubility product is, in this case, the concentration of NH4 plus times the concentration of the NO3 minus, right? And if it was something like calcium chloride that was dissociating into 1 calcium 2 plus and 2 chlorine 1 minuses, then the KSP would be the concentration of calcium 2 plus and then the concentration of chlorine 1 minus squared, just like equilibrium constants. And this basically, all this is an equilibrium constant, just we don't divide by the initial thing because initially, really it's not aqueous, it's a solid salt, right? and you can't find the concentration of a solid because it's not in solution. So that is what the solubility product does. And this one basically is going to give you sort of a steady state equilibrium. This will give you the how do we call it? Saturation concentrations. So the saturation concentration of NH4 and the saturation concentration of NO3, if you multiply them together, you'll get that solubility product. And so you can look it up in a table like other constants. Well, I hope that helps. I went a little bit over, hopefully to show you kind of why we might do a dissociation equation like this. It looks pretty simple, but it does have some important ramifications in terms of finding equilibria or finding rates. And yeah, so I hope that was helpful. And if you have any questions, please feel free to contact me. You can contact me through my Wyzant page. I think the link will be below this video. And I would be happy to help you one-on-one. All right. Have a lovely day, and I hope to see you soon. Bye.